All right, welcome to another lab demonstration video for our Chem 1212 lab here in North Georgia. So for today's experiment, what we're going to be taking a look at is trying to determine the Ksp for potassium hydrogen tartrate. So Ksp, real quick, just kind of what it is. It's what's called a solubility product constant. It's an equilibrium constant for specifically any ionic salt dissociated in water. So that's what we're going to be kind of looking at today. Now, a couple things here kind of at the start. If our goal is to find this equilibrium constant, and it's a solid going to two ions, really what we want to do is find the ions of this potassium hydrogen tartrate, so like the potassium ion and the hydrogen tartrate ion. We want to find those concentrations that are going to be in a solution that's saturated with the hydrogen tartrate. So I have a saturated solution of the hydrogen tartrate already made. And what we're going to end up doing with it is we're going to take that solution and react it with sodium hydroxide. Now, the reason we're going to do that is that we need to find out what is the concentration of those ions in here. Well, one of the ways we can do that is by doing a titration. In particular, we can take advantage of the fact that hydrogen tartrate as an ion is actually still a weak acid. And if we have a weak acid, that means we can react it with a base, which in this case is going to be sodium hydroxide, and that's what's going to be in our burette in this case for the experiment. So by doing this titration, our goal is to find the concentration of the hydrogen tartrate ion, which once we have that, now we can find Ksp. That's kind of the general thought process to things. Now, a few things in general about titrations before I get to demonstrating the experiment itself. For most titrations, our goal is to have some unknown concentration that we're starting with. And then for our solution that we're going to be putting to our burettes, we're going to know the concentration of it, and then we're using the burette to measure the volume of it that we're going to add. And by knowing the concentration and the volume of what we call our titrant that we add during our reaction, that lets us find the moles of the titrant that we're adding. So in this case, we have a way to find moles of NaOH. Once we know moles of NaOH, if it's an acid-base reaction, in this case, it's a 1-to-1 stoichiometry for the acid and the base. So for every 1 mole of the sodium hydroxide we have, that's 1 mole of our hydrogen tartrate that should have been in our starting solution. So knowing the concentration and volume of hydrogen tartrate, of the sodium hydroxide that we add, lets us find then the concentration eventually of our hydrogen tartrate that we're starting out with. So that's, again, kind of the general layout of things. Last thing I'll point out here for titrations before I get into demonstrating anything. So our goal and kind of how we know a titration is done and how we know the moles of our base and the moles of our acid that are reacting are going to be the same is to typically use something that's going to give a visual color change called an indicator. In this case, that indicator is going to be something called phenolphthalein. So phenolphthalein is a compound that once there's an excess of base in solution, so basically to any kind of basic pH, especially around like 10 or so, then the solution will start to turn a dark pink kind of purple color. So this solution that you see right here, this is a solution that's relatively basic, probably farther than we would ever want our titrations to get to. So our goal, if this is like a pH that might be somewhere like 8 or 9 or higher, even closer to maybe 10 or 11, if we want to get a really accurate measurement of the moles of acid that are in our starting solution, we actually want to aim for ending our titration when we have just a really, really faint pink color. And when I hold it over here, it might even look clear. It's a lot part of why I have the white paper in the background. And if you're doing titrations that have visual indicators, sometimes it's a good idea to do them on top of a white sheet of paper. It's easier to see the color distinctions if you do it that way, and that's why I have that there. So that's the goal. We're going to aim for doing a titration that ends hopefully looking something like this. And what I'm going to do is just kind of walk through all of the steps of this procedure to hopefully get us to that point. So the very first thing we're going to do for this reaction and titration and kind of our overall procedure, we're going to be measuring out the amount of the hydrogen tartrate we're going to use. Because even if we know the volume and the concentration of the hydroxide, and I'll show its concentration in a minute, we still need to know the volume of our hydrogen tartrate solution in order to know what its concentration is going to be. Right? Because everything else we're going to find is based on moles, so the volume is the other piece that will let us get our concentration that we need for the Ksp itself. So to measure the volume, what we're going to do is use something called a volumetric pipette, and that's what I'm holding here. This is a 25 milliliter volumetric pipette. It's got a marking on it right here. If we fill the liquid level in this pipette exactly to that marking, we have really, really accurately exactly 25 milliliters for our volume. Much more accurate than, say, a graduated cylinder that we might use otherwise. And so we're going to use this volumetric pipette, and I'm going to kind of demonstrate that here real quick to measure out the volume of our starting acid solution, or KHT. And so what I'm going to use to do that, I'm going to use this bulb. along with our pipette. And if you've never used something like this, if you never used like a bulb and a pipette like this, how you go about actually using them, you're going to want to squeeze the bulb first, put the bulb on top of the pipette so that it makes a seal, and then let go of the bulb so it's going to suck up the liquid. That's kind of the general process for this. But since this pipette is so large, even if I let the bulb expand as far as it possibly can while I'm doing this, you're going to notice the liquid level, if you can see it, is still only right about here in the pipette. It's only about halfway. And so notice what I did as soon as I took the bulb off, I actually capped the pipette with my thumb. The reason is that keeps the liquid sealed and keeps it from draining out. Because as soon as I let go of my thumb, you see the liquid level start draining. So that's how we kind of control the liquid level inside the pipette. So I'm going to go ahead and pull out more and kind of try and fill my pipette here. And that wasn't a very good seal when I first put it on here, so I'm going to take probably one more squeeze. Right, and the goal is I want to pull the liquid level slightly higher than the line I'm trying to aim for, because as soon as I pull the bulb off, that liquid level is going to start dropping. And so I'm going to pull the liquid level a good bit above the line, but not up into the bulb itself, and then immediately cap it with my thumb. So my liquid level's up here, the line's down there. Now with my thumb, I can control kind of easing off the pressure and slowly letting that liquid level get down to the line that I want it to be at. So I'm going to let it drain down just a little bit. Then clamp down. Now if I show this, I have my liquid level, the bottom of that meniscus is almost right on top of that line. Now I have the right volume that I want. Now I'm going to go ahead and add that solution that's in the pipette to my flask that I'm going to do the titration itself in. So while I'm adding this, I'm also going to kind of add another step in here. For my acid solution, something you have to make sure you don't forget for any of these titrations, if you forget to add your indicator, that's going to give you your visual color change to know when your reaction is done, you'll be here all day adding your titrant and never see a color change. So while this pipette is draining, I'm also going to go ahead and add my phenolphthalein. Actually, my pipette's about done. So my pipette has finished draining at this point. So now I'm just going to add a couple drops of the phenolphthalein. And 3 drops there should be plenty to see any color change. You don't really need more than that. You don't have to add a lot of it. It's a very colorful compound when you get to the right pH. All right, so now my acid solution is ready to start the titration. So the other part of things for getting ready before I start the titration itself, I have to get the sodium hydroxide part ready. And so for this burette, what I'm going to do, especially since I'm not particularly tall, I'm going to lower this a little bit because I'm going to have to add the sodium hydroxide at the top to fill this up some. And generally speaking, if you're adding a base or an acid to a piece of glassware like this, probably want to be careful not to spill it on yourself, so a funnel is probably a good idea. So I'm going to go ahead and add a funnel to this. And so I'm going to add my sodium hydroxide, and I just want to be careful not to fill the sodium hydroxide level so high that I can no longer measure its volume. Right, that's the biggest thing I want to look out for. I probably want to keep a little bit of space there so the funnel drains. What I did there is just lift up some of, I basically just lift it up slightly on the funnel, because if I let it sit there, it can actually make a seal and the funnel doesn't drain very well, so that's what I was doing there. So notice I didn't fill my liquid level all the way up to the top. My liquid level is actually sitting down here a little bit past 16, and I'll make note of what that measurement is here in a moment. But what I'm now going to aim for, now that I've added my base, I just want to make sure I record this number of where I'm starting, and then I'm going to record again of where I'm ending. And the important thing is I have a little bit of already kind of foreknowledge here because I've already done a couple trials. I know that for this experiment, it's going to take somewhere in the ballpark of like 24 or 25 milliliters to do this reaction. So as long as I have more than 25 milliliters of volume here that I can measure, I should be okay for doing this titration. Right now, if I want to record this measurement, looks like it's at about 16.10 for a volume. So I'm going to record that as a starting volume. And I'm going to raise it back up. And one other thing about when you're making these volume measurements, you want to be, and notice you probably saw me bend down as I made the measurement, you want to be pretty much at eye level. If I'm reading a volume that's up here near 0 and I have the thing all the way up here, and I'm looking at it from this angle, like I'm not going to be able to make a very accurate reading. Right? So always have it at eye level when you're making your measurements from your burettes. Alright, so now that I have my sodium hydroxide, I'm going to go ahead and set things up. And I'm going to do one last thing here where I can check our concentration for a sodium hydroxide solution. Apologize for kind of moving around a little bit here. So here's our sodium hydroxide solution. Sorry. It's about concentration about 0.167 molar. So that's going to be our concentration that I said that we have to know of the titrant. And then we'll measure the volume that we're going to have to add over the course of this reaction. So at this point, I should have everything pretty much ready to go. I've added my phenolphthalein. I have the acid measured out. I have my base all in my burette ready to add. So at this point, I can go ahead and start adding my base. If you haven't done any trials yet, if it's your first trial, if you want your first trial to be accurate, you want to add really slowly because you have no idea how much it's going to take to do this neutralization. And so by adding slowly, you're just kind of safeguarding that the reaction doesn't finish and you're not ready yet, basically. Like I said, I have a little bit of foreknowledge. I know about what volume I need to add. So instead of starting out and doing the entire reaction where I'm just adding kind of drop-wise like this as a general pace, or just kind of like drip, 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 to add 25 milliliters that way is going to take a really long time. So having that knowledge, since I've done a couple trials, I can now speed this up some. But again, if it's your first trial, you couldn't really do this, you want to go slow. Or sometimes what will happen, especially if you're going like analytical chemistry or other classes, you may use your first trial as almost kind of like a burned trial where you just very quickly add and see approximately where that color change took place so that your future trials you can do quickly, and that may actually even save you time in the long run. The downside is you could waste reagents if your first trial wasn't very accurate. And so kind of keep that in mind. That is something that some people will sometimes do. That's how you sometimes can end up with solutions that might look like this color, for instance. In my case, since I do know about the volume I'm going to need to add, I'm going to speed this up a little bit. So I started at 16 milliliters. If I need about 24-ish to get to my equivalence point, I think, I'm going to add pretty quickly down to about 36. And as I add, one of the things you really should be doing is mixing your solution good. Because as you mix your solution, that's going to keep everything kind of even throughout it, keep pretty constant concentrations everywhere. And the other thing you're going to notice, you're starting to see more and more pink color form. I'm going to slow this down a little bit. There's more pink color that forms as I add the sodium hydroxide, but as I stir it, the pink color goes away. And so if you aren't stirring your solution constantly, it can sometimes be hard to know when you actually hit your end point for your reaction, because all of your pink color might just be in the center of the solution, and then you swirl it, and the whole thing is a dark pink color. And so you want to kind of avoid that, kind of constantly mix your solution, especially as you get closer to what you expect the end point of your titration to be. So right now I've added a little less than 20 milliliters. I'm going to start adding again, but at a much slower rate, where now it's going to be kind of drop-wise. And you'll notice here, again, the pink color is forming, so now I can go ahead and basically just kind of constantly swirl this solution as I'm going drop-wise. And I'm just going to wait for, as I get closer to what should be the end point of my experiment, the color is not going to go away when I actually go ahead and swirl and stir the solution. So eventually one of these drops are going to hit, you're going to swirl it, and the pink solution is going to go everywhere and stay there. And that's what we're really trying to get to. That'll be our end point for this reaction. Sorry for kind of the quick cut out there. So we are very close to our end point here, so we're just a little bit more volume to go. Notice, add a few drops, I'm going to swirl it. I really don't want to add any more because the pink color is now taking a while to go away. So I really want to be slow about adding my remaining drops. Try to get just a single drop here. Stir it, see if that color starts going everywhere. No, not quite yet. At this point at the end, one drop at a time is probably ideal. A second drop out of it. Still waiting for the color to stay. Just 2 drops that time. Getting really close for it staying around. It's taking longer for it to go away than we had before. And there, after a few swirls, you might actually already be able to see, it might be a little bit hard in the video. From here, it looks like there's a tiny, tiny, tiny tinge of a pink color. Although once I've stirred it and let it sit for a minute, it didn't quite stick around. So I should be really, really close at this point. So I can try to get just one more drop and see if that's all it takes to kind of get us to a stable pink color that will stay. And again, if I'm trying to tell, like, is there a pink color to it or not, looking at the paper, maybe. It's really, really close. For the sake of being able to see in the video, I'm going to add just a tiny bit more so you can hopefully get a very distinct color change here. There's a couple drops, and now I should see a much clearer pink color that's actually stained, but it's still very light. Right? We're nowhere near what the dark color is over there. And if I stir and mix this and let it sit for a couple minutes, that really light pink color should stay. So this should be my end point that I'm trying to get to. I have that really light pink color that's sticking around. It's good. Now I should be done as far as how much I've actually added. Now, I did have to go back, unfortunately, and make an adjustment of this from like my video cutting out, like the first time I was in the process of draining this. So I'm actually going to give you the measurements that we are going to need to use here. So this final volume measurement looks like it's about 32.70 milliliters. And I started this one actually at 9.12 as a starting point. So that gives us a little bit, so I apologize for having to kind of reset the initial data point that I mentioned. Like I said, I will include an email that have all of the data points in them. But for this trial, started at 9.12 milliliters, ended at 32.70 milliliters. So we can take the difference to find the volume that we added to get to that endpoint. And now with that volume of sodium hydroxide, along with our concentration for that solution, I can find the moles of sodium hydroxide that I added. And if I know the moles of sodium hydroxide, that's the moles of the acid that must have been in my starting 25 milliliter solution. So if I know its moles and I know it was 25 milliliters, I can use that to find the concentration of the hydrogen tartrate ion. And once I have the hydrogen tartrate ion concentration that I started with, I now can multiply that, basically square it, multiply it by itself, because the potassium ion concentration should be the same concentration, because it's a 1-to-1 ratio for the ions in that salt, and that should give me then my resulting KSP. So those are kind of just real quick verbally the steps that you'll be doing for the calculation portion then of this lab. Last couple quick notes, things like waste and safety. From a safety perspective, titrations, we're pretty much always dealing with acids and bases. So we always want to be careful in terms of their general handling. Gloves, not a terrible idea, although these concentrations are very small that I'm particularly working with right now. So if I get a little bit on my hand, not the end of the world, I can just wash it off, it's going to be okay. Disposal, like waste, things like that. There are some titrations you might be able to put down the sink right away, but if you're doing things like hydrogen tartrate, not necessarily something we immediately want to send down the sink. Like if you have lots of phenolphthalein, again, same thing, maybe you don't want to put all that down the sink. So a lot of different titrations probably are going to have waste disposal that you do have to pay attention to. So do be kind of aware of that in the future. A lot of titrations might have to take some extra caution in terms of how you get rid of them. Some of them, when you're done, you may just be able to send straight down the sink. Particularly things like, like HCl and NaOH, if you do a titration with those two, if you don't have any like phenolphthalein or other stuff there that might be a problem to send down the sink in a large quantity, then you should probably find to send some like those products down the sink. So there are instances where that might come up, but most of the time not necessary. Anyway, that's all I have for this week's lab as far as kind of the demonstration side of things. If you do run into any questions or problems trying to do any of the calculations, please feel free to email myself or whoever your individual instructor is. We'll be happy to kind of reach out and help, and I will see you then next time.